Do you know that the sum of two squares can now be factorized without using imaginary number I? After watching this video, you will know that the sum of two squares can be factorized without the use of imaginary number I. Then you will see the wonders of God in mathematics. So let us proceed. Let's consider x squared plus 4. This is an example of the sum of two squares. We are going to factorize the sum of two squares without the use of imaginary number I. So to do this, the first and foremost thing that should be done is that we should add and we should subtract. The rationale behind adding and subtracting is for us to find a set of trinomial that can easily be factorized. So in this problem here, x squared plus 4, we will be adding 4x and be subtracting 4x. So here, if we do this, we have x squared plus 4x minus 4x plus 4. Nothing changed here. We can easily see that positive 4x and negative 4x can easily cancel out, and we are left with x squared plus 4. After adding and subtracting, we will rearrange minus 4x and positive 4 by bringing positive 4 before negative 4x. So when we do this, we will have x squared plus 4x plus 4 minus 4x. Now, we can now clearly see a set of factors that we have here that can easily be factorized. So we can see that x squared plus 4x plus 4 is a trinomial and it can easily be factorized. So when factorize x squared plus 4x plus 4, we will have x plus 2 equals all squared minus 4x. We have now made life extremely easier for ourselves. We can now see that x plus 2 can be represented by any variable like x. We cannot use x because x is already prominent, or like y, like z, any unknown variable you want to use. But since my name is dependable, I will say let t be equal to x plus 2. It left for you to use your initials. Mathematicians will not sue you for that. So I will say let d be equal to x plus 2. So at this point, where I see x plus 2, I will replace it by d. So if I do this, I will have d squared minus 4x. Now, we can easily see that d squared minus 4x can be factorized. So factoring this, we have d squared means d times d, negative mean negative times positive, 4 mean 2 times 2, and x mean the root of x times the root of x. So we have factorized d squared minus 4x. But d was not in our original problem given to us. D was only substituted by an expression. So we need to replace d by 8 original expressions. So d is equal to x plus 2. Where we see d here, we replace d by x plus 2. So doing this, we have x will now bring minus 2 root x before this plus 2. X minus 2 root x plus 2. We'll do the same in second family. We have x plus 2 root x plus 2. We have now factorized the sum of two squares without the use of imaginary number I. If we can prove this to carry back to the original problem, then we will appreciate God for giving Dependable Reeves the idea to solve this particular problem here. Because mathematicians told us that this problem cannot be factorized. It is unfactorable, or it can only be factorized by using I. So let's see how we can prove this. So in proving this, we do our simplest modifications. So we have x times s give us s squared. X times positive 2 root s give us plus 2x root s. X times positive 2 give us positive 2x. Minus 2 root x times s give us minus 2x root x. Minus 2 root x times positive 2 root x give us minus 4x. Minus 2 root x times positive 2 give us minus 4 root x. We move to the next one. Yeah, minus 2 root x times positive 2 give us minus 4 root x. And we move to positive 2 times x give us plus 2x. Positive 2 times positive 2 root x give us positive 4 root x. Positive 2 times positive 2 give us positive 4. We can clearly see that positive 2x root x cancel negative 2x root x. And minus 4 root x cancel positive 4 root x. Now, we left the s squared. We can see that positive 2x and positive 2x can be added to positive 4x. Now we have minus 4x. So we write our minus 4x down plus 4. We can now see that positive 4x and negative 4x can cancel out. We are left with s squared plus 4. You see how God is wonderful. So let's give God the praise. Now, let's solve our second problem again. So now let us consider 4s squared plus 9. Let's factorize this again without the use of imaginary number I. To do this, I told you previously that the first and foremost thing need to be done is for us to add and to subtract. The essence of adding and subtracting is that we want to find a set of trinomials that can easily be factorized. We're doing this to make life extremely easier for ourselves. So let's do this. So here we have 4s squared plus 12x minus 12x plus 9. I know somebody will ask me, how do we come up with the 12x to be added and to be subtracted? Now the answer is very simple. Here is your answer. To obtain the number that will be added or subtracted, take the what? The square root of the last term. The last term here is 9. So the square root of 9 here, we have 3. Multiply 3 by the coefficients of the variable news. The coefficient of the variable news here is 4. 4 times 3 give us 12. Now multiply the product by the variable news. 12 times x give us 12x. So 12x will be added and will be subtracted. But in the previous problem I gave you, we have s squared plus 4. That's what we have. So here, what I did here is that I took the square root of 4. The square root of 4 gave me 2. I know that the coefficient of the s squared is 1. When the coefficient of the variable is 1, do not multiply by 1. Multiply by 2. So I said 2 times 2 gave me 4. And I use 4 and multiply by the variable news here, which was x. So 4 times x gave me 4x. Now I obtain the 4x to be added and to be subtracted. So then we move. So here, after doing our addition and subtraction, we can rearrange the two last terms. We bring the last term before the next to the last. So doing this, we have 4s squared plus 12x plus 9 minus 12x. We can clearly see that we have a set of trinomials that can easily be factorized. So factoring 4s squared plus 12x plus 9, it gives us 2x plus 3 equals all squared minus 12x. Now, we have again made life extremely easier for ourselves. We can use any variable or letter to replace this expression 2x plus 3 to make life easier. Now, since my name is dependable again, I will use D. I will say let D be equal to 2x plus 3. So where I see 2x plus 3, I'll replace it by D. So doing this, I have D squared minus 12x. I can now see that D squared minus 12x can easily be factorized. So factoring D squared minus 12x, we have D squared means D times D. Negative means negative times positive. 12 means 2 root 3 times 2 root 3. And then x means root x times root x. So x will remain in the root here because x is not a perfect square also. So here we have factorized. So let's write this clearly. So here we have d minus 2 root 3x, and we have d plus 2 root 3x. Alright, now d was not in our problem given to us. So we will now do our substitution. Where we see d, we place d by 2x plus 3. So doing this, we have 2x minus 2 root 3x plus 3, a closing the first parenthesis. The second one we have 2x plus 2 root 3x plus 3, a closing. So we have now factorized the sum of 2 squared again without using imaginary number r. So today you are strongly convinced that the sum of 2 squared can be factorized without using imaginary number r. To conclusively conclude, let us prove this. Let us multiply the two factors to see whether we can come back to our original problem. Then we can be convinced that the sum of 2 squared can be factorized. So let us do our proof. So here, our factor given to all here, we have 2x minus 2 root 3x plus 3 plus a, and we have 2x plus 2 root 3x plus 3 plus a. So let us do our modification. So here we come to say 2x times 2x, they are 4x squared. Good. So we come 2x times positive 2 root 3x, they are positive 4x root 3x. 2x times positive 3x, they are positive 6x. Minus 2 root 3x times positive 2x, they are minus 4x root 3x. Minus 2 root 3x times positive 2 root 3x, they are minus 12x. Minus 2 root 3x times positive 3, they are minus 6 root 3x. Moving last time, 3 times positive 2x, they are plus 6x. Positive 3 times positive 2 root 3x, they are positive 6 root 3x. Positive 3 times positive 3, they are positive 9. So let's look here. We can now see that positive 4x root 3x will cancel minus 4x root 3x. And we can also see that negative 6 root 3x will cancel. So minus 6 root 3x cancel positive 6 root 3x. Now we can now see that we left with 4x squared. We can see that positive 6x and positive 6x can be added. So we add positive 6 and positive 6x, we have positive 12x. And we have here minus 12x. So here we have minus 12x down. And here our last thing we have here is positive 9. Positive 9. We can now see that positive 12x and negative 12x can cancel out. So positive 12x and negative 12x cancel out. After the cancellation, we are left with 4x squared plus 9, which gives us our original problem. So you see how God is wonderful. So let's give God the praise. Thank you for watching my video. Please subscribe. I love you, but Jesus loves you most. Thank you for your time. I'll see you in my next video. Please give the video a thumbs up if you like it, or give it a thumbs down if it is like it. Thank you.